Good day everyone, I'm John Michael De Rosario and today ay i-discuss natin ang types of solar power plants. Specifically, photovoltaic systems and solar thermal systems. So, ang solar power is one of the most important sources of renewable energy in the world today. It comes from the sun, which provides a clean, abundant, and sustainable source of energy. So, hindi kagaya ng fossil fuel, ang solar energy ay hindi nagpo-produce ng harmful emissions, making it environmentally friendly. So, because of this, many countries, including the Philippines, are investing more in solar power plants. So, meron tayong two ways na hina-harvest ang solar energy. So, una ay ang photovoltaic systems and ang pangalawa ay ang solar thermal systems. So, una, dito tayo sa photovoltaic systems or PV systems. Ang photovoltaic systems ay kino-convert ang sunlight directly into electricity using solar panels. So, these panels are made up of materials like silicon that can generate electric current when exposed to the sunlight. This process is called the photovoltaic effect. When the sunlight hits the panel, it excites electrons, creating a flow of electricity. This electricity can then be used to power homes, buildings, and even entire communities. So, bakit nga ba common type of solar power plant ang photovoltaic systems? Kasi they are easy to install, they require low maintenance, they can be used in small scale setups like rooftops or large scale solar farms. So, for example, sa ngayon is marami ng bahay na gumagamit sa rooftop nila ng solar power plants para ma-reduce yung electricity bills. Next is the solar thermal systems. So, hindi gaya ng PV systems, ang solar systems ay hindi directly napoproduce ng electricity from sunlight. Instead, they use the heat from the sun. Large mirrors are also called reflectors because they focus sunlight onto a specific point. This concentrated heat is used to heat a fluid, usually water, and produce steam. Then the steam spins a turbine connected to a generator which produces electricity. So compared sa PV, ang PV ay gumagamit ng light directly, samantala naman, ang solar thermal ay ginagamit yung heat para sa pang-unang process. So solar thermal plants are usually large scale more complex, and it is used for power generation in utility level plants. So to summarize the difference, ang photovoltaic systems ay direct conversion of sunlight to electricity. Ito ay mas simple at mas common at mas ginagamit sa bahay at sa mga solar farms. Samantala naman, ang solar thermal systems ay gumagamit ng heat para mapa-generate ng electricity, and ito ay mas complex at mas ginagamit siya sa mga power plants. So, in conclusion, ang solar power plants ay isang essential part of the shift toward renewable energy. Both photovoltaic systems and solar thermal systems help us harness the sun's energy, but they do so in different ways.
My name is Gian Mayron Abregos, and our topic is about physical components of a solar panel. A solar, a solar panel is a device that turns sunlight into electricity. Inside it are solar cells, but these cells are very delicate, so they can easily get damaged. To protect them, the solar panel is built like a sandwich with different layers. Each layer has a job. Some protect against rain and heat. Some hold everything together. And others help the panel work properly. All these layers working together to keep the solar cells safe and make sure the panel lasts a long time while still letting sunlight in to produce electricity. In short, A solar panel is a carefully layered to protect its parts while still, while still doing its job of making electricity from sunlight. Structure of a solar panel. A typical solar panel is made up of the following layers. First, tempered glass. The tempered glass is the top part of the solar panel. It is a strong, transparent layer that covers and protects everything inside. It protects the solar cells from rain, dust, hail, and strong impact. At the same time, it allows sunlight to pass through easily so that panel can produce electricity. The tempered glass acts like a tough shield that keeps the panel safe while still letting sunlight in. Next, encapsulant or EVA, ethylene vinyl acetate. The encapsulant is a special clear layer inside a solar panel that sits around the solar cells. It holds the solar cells firmly in place. It protects cells from moisture and it also reduces damage from vibration and small shocks. Next, solar cells. The solar cells are the most important part of a solar panel because they are the ones that actually produce electricity. They convert sunlight into electricity. This is the main energy producing part of the whole solar panel. This is the part that catches sunlight and turns it into usable power. How it works? Solar cells are made from semiconductor materials, usually silicon. When sunlight hits the silicon, it activates electrons inside the material. This process is called the voltaic effect. The movement of electrons create an electric current. Next, backsheet. The backsheet is the bottom layer of a solar panel. It acts as the final protective cover at the backside. Function protects the back of the solar panel and prevent moisture, dust, and dirt from entering inside. Next, aluminum frame. The aluminum frame is the outer structure that surrounds the solar panel. It holds all the layers together and gives the panel its final shape. Next, junction box. The junction box is a small but very important located at the back of the solar panel. It is where the electricity produced by the solar cells is connected and sent out. Next, durability. Solar panels are designed to 20 to 25 years or more. They must survive different weather conditions like heat from the sun, heavy rain, and strong winds. Next, efficiency. Materials must allow maximum sunlight to enter and be converted into electricity. Engineers aim to reduce energy loss as much as possible. Simple idea. More sunlight, more sunlight in is equal to more electricity out. And last, safety. Electrical parts must be properly insulated to avoid shocks or hazards. The junction box helps control and safely send electricity out. The system must be safe for people and devices.
Good day everyone. I am Julian Niel Espangilinan from BSEE3B. Today, I will be discussing light absorption and anti-reflection in solar cell. This topic is very important because it directs affects how efficient a solar panel is in producing electricity. Solar panel works by converting sunlight into electrical energy. However, not all sunlight that reaches a solar panel is absorbed. Some of the light is reflected away, which reduces the amount of electricity that can be generated. Because of this, improving light absorption is one of the most important factors in increasing solar panel efficiency. One of the main challenges is the silicon, which is the most common used material in solar cell. Is naturally shiny. Because of this shiny surface, silicon reflects about 30% of incoming sunlight. This means that the nearly one-third of the sunlight is lost before it can even be converted into electricity. This is where anti-reflection coating becomes important. Light absorption in solar cell. Light absorption in the process where the solar cells capture sunlight and convert into electrical energy. The more sunlight that is absorbed, the more electricity the solar panel can produce. When the sunlight hits the surface of solar panel, three things can be happen. Light can be absorbed, light can be reflect, light can be passed through the materials. For solar panel to be efficient, most of the sunlight must be absorbed. If too much light is reflected, the solar panel loses potential energy. The absorbed sunlight contains photons, which are particles of the light. These photons carry energy. When photons enters the solar cell, they excite electrons inside the silicon materials. These excited electrons then move and create electric current. This is the basic principle of how solar panel generate electricity. Next is silicon reflect lights. Silicon is the most commonly used materials in solar cell because it is efficient, reliable, and widely available. However, silicon has one disadvantage. It reflects a large amount of sunlight. The surface of silicon is naturally smooth and shiny, similar to a mirror. Because of this, when sunlight hits the surface, some of the light bounces off instead of entering the solar cell. Study shows that untreated silicon can reflect around 30% of incoming sunlight. This means that without improvements, solar panel would lose a significant amount of energy. This reflection reduces the overall performance and efficiency of the solar panel. Because of the problem, engineers develop solutions to reduce reflection and increase absorption. This is what we call anti-reflection coating. One of the most effective solutions is anti-reflection coating. Anti-reflection coating is a thin layer of material placed on the surface of solar cell. This coating helps reduce reflection and allow more sunlight to enter the solar cell. This coating works by minimizing the amount of light that bounces off the surface instead of reflecting more. Photons enter the silicon material. Common material used for anti-reflection coating include silicon nitride. titanium dioxide and silicon dioxide. These materials are especially designed to reduce reflection and improve light absorption. Anti-reflection coating also help trap light inside the solar cell. This means that even if the light tries to escape, it reflects back into the silicon materials. This increases the chances of photon being absorbed and converted into electricity. Next slide is how anti-reflection coating improves efficiency. Anti-reflection coating improves efficiency in several ways. First, it reduces surface reflection. This allows more sunlight to enter the solar cell. Second is it increases photon absorption. More photons means more energy available to generate electricity. Third, improves performance even during low light sunlight condition. This helps solar panels generate electricity even on cloudy days. Fourth is it enhances overall solar panel efficiency. With anti-reflection coating, solar panel can produce more electricity using the same amount of sunlight. Because of this benefit, anti-reflection coating are now commonly used in modern solar panels. Next slide is the textured surface with anti-reflection. Aside from anti-reflection coating, solar cells also use textured surface. The surface of the silicon is designed with tiny pyramid-like structures. This small structure help trap light inside the solar cell. When light enters, it bounces multiple times instead of escaping. This increases light absorption and improve efficiency. When texture surface are combined with anti-reflection coating, solar cells become even more efficient. This combination helps maximize sunlight absorption and minimize energy loss. Um, Next is the importance of light absorption. Light absorption is very important because it directly affects the power output of the solar panel. Better light absorption means higher electricity production, better efficiency, improved performance, reduced energy loss. Engineers and scientists continue to develop new technologies to improve light absorption. These improvements help make solar energy more reliable and cost effective. At the last page, light absorption and anti-reflection technology plays a major role in improving solar panel efficiently. By reducing reflection and increasing photon absorption, solar panels can generate more electricity from the same amount of sunlight. Modern solar panels use anti-reflection coating and textured surface to trap more light and improve overall performance.
When we look at a solar panel, we see a silent blue tinted device that turns sunlight into electricity. But how? The answer lies in a process called doping. Without it, silicon is just an expensive piece of glass. Doping allows us to engineer the flow of electricity by manipulating the very atoms of the materials. Today, we'll explore how moving from intrinsic to extrinsic semiconductors allows us to capture the power of the sun. Material classification from pure to purposeful. First, let's talk about the base material, intrinsic semiconductors. This pure silicon. In its natural state, every silicon atom is perfectly bonded to four neighbors. Because there are no loose electrons, it's a poor conductor. To make a solar cell, we must turn it into an extrinsic semiconductor. We do this by polluting the crystal through doping. The doping ratio. To understand how powerful this is, consider the scale. We add about one dopant atom for every 1 million silicon atoms. That's like adding a single drop of ink to a massive water tank. Yet, this tiny change increases the material's conductivity by several orders of magnitude, turning it from an insulator into a functional electronic component. The atomic chemistry. To create a solar cell, we don't just dope silicon once. We create two distinct types of materials to form a junction. This involves looking at the valency of our dopants. First, let's talk about the N-type doping. On the top layer of a solar cell, the side facing the sun, we use pentavalent doping. We introduce an element like phosphorus, since phosphorus have 5 valence electrons, and silicon only has 4. The fifth electron has no bond to hold on to. It becomes a free electron. Because we now have a surplus of negative charges, we call this N-type material. Now is the P-type doping. On the bottom layer, we use trivalent doping, usually with boron. Boron only has 3 valence electrons. When it sits in the silicon lattice, it leaves a vacancy, a hole where an electron should be. This hole acts like a positive charge. This is our p-type material. By sandwiching these together, we create p-n junction, which act as a permanent internal electric field, essentially a slide for electrons. Charge carrier dynamics. Now, how does this actually generate power? It comes down to how majority and minority carriers have behave when sunlight hits the cell. The photovoltaic action. In the N-type layer, electrons are the majority carriers. In the P-type layer, holes are the majority carriers. When a photon from the sun hits the silicon, it knocks an electron loose, creating an electron-hole pair. Now let's talk about the hole migration and electron flow. This is the aha moment of semiconductor physics. Electron flow. The free electron is pushed by the internal electric field toward the N-type side. While hole migration, the hole is pushed toward the P-type side. Think of a hole like a vacancy in a row of chairs. If the person in chair B moves to chair A, the vacancy moves to the chair B. Even though the people are moving one way, the vacancy effectively moves in the opposite direction. In a solar cell, this simultaneous migration is what creates a continuous electric current. As conclusion, doping is the fundamental chemistry that turns a rock silicon into a source of infinite clean energy.
So ngayon dadako naman tayo sa formation of the PN junction. Sa previous discussion natin, napag-usapan natin ang doping process kung saan ang pure silicon ay nilalagyan ng impurities para maging mas useful sa electrical applications. So quick recap lang tayo. Kapag nagdadagdag tayo ng pentavalent atoms tulad ng phosphorus, nagiging N-type semiconductor. Ito, ibig sabihin, mas marami itong free electrons. Samantala kapag trivalent atoms tulad ng boron ang dinagdag, nagiging p-type semiconductor kung saan holes naman ang majority carriers. Ngayon, i-connect natin ito sa main topic natin na solar energy process. At pag-usapan natin kung paano nabubuo ang pinaka-importanting part ng solar cell, ang p-n junction. So, yung formation of p-n junction, kapag pinagdikit natin ang N-type at P-type silicon, nabubuo ang tinatawag na p-n junction. At hindi lang ito simpleng connection. Dito nangyayari ang foundation ng energy conversion sa solar panels. Movement of charges. Sa N-type side, maraming electrons. Sa P side, maraming holes. Dahil sa difference na ito, automatic na gagalaw ang charges. Ang electrons mula sa N-type ay tatawid papunta sa P-type. Ang holes mula sa P-type ay pupunta naman sa N-type. So, ang process na ito ay tinatawag na diffusion. Merong maraming process, katulad ng recombination process. Kapag ang electron ay napunta sa P-side type, makakahanap ito ng hole. Kapag nag-meet sila, nagkakaroon ng recombination.
Ibig sabihin, nawawala sila bilang free carriers. Habang tumatagal, nauubos ang free electrons at holes sa area malapit sa junction. Meron tayong depletion region. Dahil sa recombination, nabubuo ang isang region kung saan wala ng free carriers. Ito ay tinatawag nating depletion region. Depleted siya dahil wala ng mobile charge dito. Pero may natitira pa ring charges, kagaya ng mga fixed ions. Sa N-side, positive, and sa P-side is negative ions. Meron din na-develop na internal electric field. Dahil sa presence ng positive at negative ions, nagkakaroon ng separation of charges at dito nabubuo ang internal electric field. Ang direction nito ay mula N-side papunta sa P-side. Ang electric field na ito ang napaka-importanting bahagi ng PN junction, lalo na sa solar energy. PN junction as a battery. Dahil sa internal electric field, parang nagiging mini battery ang PN junction. May built-in energy siya even without external voltage. Hindi pa siya nagpo-produce ng current agad, pero handa na siyang mag-function kapag na-activate. At dito papasok ang role ng solar energy. Kapag ang liwanag ng araw ay tumama sa PN junction, nagkakaroon ng energy photons. Ang energy na ito ay ginagamit para mag-create ng electron-hole pairs. Ngayon, dahil may internal electric field, ang electrons ay tinutulak papunta sa N-sides. Ang holes ay tinutulak papunta naman sa P-side. So, instead na mag-recombine agad, nahihiwalay sila. Doon pumapasok yung generation of electric current. Kapag ang electrons ay dumaloy sa external circuit pabalik sa P-side, nagkakaroon ng electric current. At ito na ang electricity na ginagamit natin mula sa solar panel. Ngayon, ang importance of PN junction is sa solar cell dahil siya ay nagse-separate ng charge, nagko-convert ng light into electrical energy, nagbibigay ng direction sa flow ng current. Without PN junction, hindi magiging efficient or hindi gagana ang isang solar cell. Ngayon, connected ito sa doping. Balikan natin ang doping process. Kung walang doping, wala kang N-type at P-type. Wala kang PN junction. So, ang doping ang unang step at ang PN junction ang result na ginagamit natin para makagawa ng solar energy conversion. In summary, doping creates N-type and P-type semiconductors. Kapag nag-meet, nagkakaroon ng diffusion at recombination. Doon nabubuo ang depletion region. Nagkakaroon ng internal electric field na nagme-make or nagka-act as a battery. At kapag tinamaan ng light, nagge-generate na ito ng electric current.
Sa part na ito, i-explain ko ang pinaka-importanting parte kung paano gumagana ang solar panel. Ito ang photovoltaic effect. The photovoltaic effect is the process where the sunlight is converted directly into electricity. This is the core principle behind solar panels and why they are able to generate power without a moving parts. To understand this, let's start with the light itself. Sunlight is made up of tiny particles called protons. These protons carry energy, and when they reach the surface of the solar panel, they interact with the material inside, which is usually silicon. When this photons strike the solar cell, the energy is transferred to an electron in the silicon atoms. If the energy is strong enough, it knocks this electron loose from their atoms. This is called excitation.
Now, at this point, um, free na yung electron. But electricity is not just about having free electrons. It requires movement. This is where the internal electric field created by the PN junction, it is very important. The electric field acts like a one-way force. It pushes the free electron towards one direction, usually towards the N-type side of the material. At the same time, the host or the positive charges moves toward the P-type side. Because of this movement, electrons start to flow continuously, and this flow of electrons is what we call electric current. This generated electric current is a direct current or a DC electricity. It flows in a single direction, unlike alternating current used in homes. To collect this electricity, metal contacts on the top and bottom of the solar cell captures the moving electrons and send them into an external circuit. From there, the electricity can be used, stored in batteries, or sent to an inverter. It is important to understand that this entire process happens instantly and continuously as long as sunlight is available. The more sunlight that hits the panel, the more photons interact with the material and the more electricity is produced. However, efficiency depends on how many photons are successfully absorbed. This is why earlier we discussed anti-reflection coating and proper panel design because they help maximize the number of photons entering the cell. To conclude all of that, the photovoltaic effect involves 3 steps. First, the sunlight or photons hit the solar panel. Second, electrons are knocked loose from atoms. Third is the internal electric field forces these electrons to move, creating an electric current. Without the photovoltaic effect, solar panels would not be able to generate electricity. It is not the fundamental process that makes solar energy a clean, renewable, and reliable source of power. And that concludes my explanation of the photovoltaic effect. Thank you.
So ngayon naman pag-usapan natin kung paano nakakarating ang kuryente sa mga bahay natin. Ang kuryenteng nanggagaling sa solar ay DC or direct current. Pero ang kailangan ng mga appliances natin at ng electrical grid ay AC or alternating current. Kaya dito na papasok ang inverter. Ang trabaho nito ay convert ang DC electricity para maging AC. So after ma-convert from DC to AC, dadaan naman ang kuryente sa mga step-up transformer. So bakit kailangan duman sa step-up transformer? Kasi kailangan i-boost o itaas ang voltahe. Mula sa mababang 480 volts, itinataas ito hanggang 13.8 kilovolts o kahit nasa 46 kilovolts. Ginagawa ito para hindi mawala ang energy habang naglalakbay ang kuryente sa mahabang cable dahil sa energy losses. And finally, kapag mataas na ang voltahe, handa na itong i-connect sa utility network at sa mga substation para i-distribute sa mga residential areas at gagamitin nating lahat. O in short, from sunlight to panels, then conversion and boosting bago maging kuryenteng nagagamit sa bahay.